morning everyone. My name is T. Harish. Today I am going to explain immutable maps, the power of the functional key value storage. Immutable maps, also known as a persistent data structure, are a powerful tools in the realm of the functioning program. Unlike traditional multiple data structures, immutable maps provide a unique way to manage key value pairs, offering significant benefits in the terms of performance, concurrence, and overall code sympathy. In this sympathy, this is the comprehensive guide. We will explore the key properties, advantages, and use immutable maps, as well as how to implement them in various program languages. So, what is immutable maps? Definition: immutable maps are the data structure that store key value pairs in the way that ensure the original data remains unchanged. When new values is associated with a key, a new map is created, and the original map interact. This effectively creates a new version of the map rather than the modify the extensive one. And next, functional approach. Immutable maps are the core component of functional programming, which emphasize the use of pure functions and it goes to the side effects also. By maintaining the original data of the structure, immutable maps enable a more declarative and predictable programming style. Reason about the behavior of its own applications also. Persistence. The key feature of immutable maps in their persistence, which means that the previous version of the maps are still accessible and can be used for reference for further mod. In this persistence, we use these immutable maps for further modifications also. The property is particular uses for scenario where you need to track the evaluation data over time or support. So we can in the persistence we can track the data and also support over the time. So in this immutable maps, the key properties are persistence, structural steering, efficient updates, thread safety. First of all, persistence. Immutable maps are retained previously version of the data. Means it retains the previous version of data also, allowing the access and without modifying the original. So it allow the access and it will not modify the original data. Next, structural sharing. Structural sharing means new version of an immutable map structure can be part of the previous version, reducing memory usage and improving the performance. In structural sharing, we can increase the memory usage and we can improve performance also. Efficient update. Modifying an immutable map create a new version without need to copy the entire data structure, which is more efficient than that updating a mutable maps. Thread safety. Immutable in thread safety can access and work with the same data also. It is in thread safety we have the risk to face something risk conditions and the concurrency issues. So here we can see beside the table, immutable maps are three ways. One is reservings and one is servers and map. So in immutable maps, the benefits we have four types. One is performance and another one is concurrency and code sympathy and debugging. In performance, the efficient update and structural sharing properties of immutable maps can lead to significant performance improvements, especially in a scenario with frequent data modifications. We can do in performance data modifications also. In concurrency, immutable maps are inherently thread safe, allowing the multiple thread to access and work with the same data without a risk, conditions or other constraints. In this, we can do same data work without having risk. Code sympathy. The functional nature of immutable maps simplifies the code, making it easier to reason about, maintain, and test. So, in this, developers can focus on a logical operation rather than the worrying about the managing mutual states. In code sympathy, we can find the reasons about maintaining and the test, and the developers also can focus on the logical operations. Debugging. The persistence nature of immutable maps makes it easier to implement features like undo and redo functionality and step-by-step debugging. So in this debugging, we can do the data step-by-step for debugging. As we know, easily revert previous version of data. So in the immutable maps, the use cases we have. First one is catching, another one is the state managing. After that, functional problem. This was happened by in step-by-step process. Catching. Immutable maps are well suited for building efficient cache system, as they can store key value pairs without risk. So in this catching, we can store the value pairs without any risk. State management. In applications with complex state, immutable maps can be used to manage the state predictable and reliable ways, making it easier to reason about and test the application behavior. In the state management, we can test the application behavior, and also it is easy to find the reason for application behavior, test for application behavior. And next, after that, first catching, after state management, after function programming. Immutable maps are core components for of functional programming, enable or more directive and side effect free programming style, which can lead to more maintainable and scalable code. First of all, functional programming. In immutable maps, functional programming are the core component, which can lead to the more maintainable and scalable code. So we can use the functional programming in a scalable code and maintainable codes also. Next, implementing immutable maps in programming language. So we can implement the immutable maps in Java, Python, and Rust. Java in JavaScript also we can. Now we can see JavaScript. In JavaScript, the built-in maps object provides a multiple key value stores, but we can also use immutable.js or immutable map to create immutable maps. So in this JavaScript, we should use definitely immutable maps.js for storing the key value storage. In Python also we can build immutable maps. In Python, how we build is built-in dictionary type is mutable, but you can use the forensic for the collections to create immutable maps. In Java also, in Java we call normally in Java how we create is by hash maps we create the immutable maps. So in Java we can use hash maps, but for immutable maps, the immutable maps from the Goa library of the maps of the entry factory methods in Java 9 plus are better option. So here Java 9 plus is a better option to create immutable maps in the Java program, particularly in Java program. In Rust we find in a tree format. So here Rust stand library provides the B tree map and the hash map type, which can be used to create both mutable and immutable maps. So in this Rust we can implement both what immutable maps and mutable maps also we can implement. The hash type support only immutable access. So here hash maps only supports the immutable access. It will not support the mutable maps. So immutable maps optimization performance. How it performance? First one is by structural sharing, batch updates, and persistent data structure. So we can observe the diagrams beside. First of all, immutable maps can leverage structural sharing, where new versions of the map that the map part of the previous data, reducing memory usage and improving the performance. Batch updates. Next one, after structural sharing, it update the batch wise. So after performing multiple updates to immutable maps in a single operation. Here we can update multiple updates in a single operation. Suppose if you take more updates was there in the maps, so we can do in the batch updates. How can we do is we can do in a single operation, we can do rather than after that rather than individual updates can significantly improve performance by reducing the number of used data structure that need to be created. So by diagram we can see that persistent data structure, specialization persistent data structure, such a finger tree or a hash array mapped trees can be used to implement mutable maps with even more efficient update and access operations. Next, in future, how immutable maps are developing, or what is the future of immutable data structure? So we can find in this format. The future of immutable data structure As that software development landscape continues to evolve, the importance of immutable data structure, including immutable maps, in accepting to grow with the increasing the focus of functional programming, currency, and scalability, and the benefit of immutable maps will become increasingly valuable. So in future, immutable data structure have a huge demand, increasingly valuable or more valuable in currency or scala. In currency means a crypto like that, we can use immutable maps. So looking ahead, we can accept to see further advancements in the implement and optimization of the immutable maps, as well as integration as their integration into more programming language and framework. Additionally, the rise of the distribution system and need for a recoverable fault tolerant data management will continue the drive the adoption of a immutable structure, solidifying their position as a crucial tool in the modern software engineer toolkit. So thank you.